Hello, Professor. I am really grateful for this opportunity to begin with. My name is Tharun Kalluru, and I am currently studying Masters in Computer Science at George Mason University. I worked as an application development associate at Accenture for 1.5 years, where I was responsible for handling the SAP sales and distribution task for the client Philips 66. During this time, I took on providing the setup for automation of several tasks, such as the plan setup, configuration in both S4 HANA as well as in R3. I have worked with Indian School of Business for Technology Entrepreneurship Program, where I took the lead of building an IoT and machine learning based kiosk, for which we were awarded with special diploma from Government of Ukraine and also recently had a patent for the work. We have also done this work in collaboration with ICRISAT, where we managed to get the sufficient data from them for our analysis. So I completed my bachelor's in 2021 from Trinity Institute of Science and Technology, Hyderabad. I'm always a self-motivated for research and development and do have good experience in research work. I have published my research work paper in International Journal for Research in Applied Science Engineering Technology. And speaking about my strengths, I am very good at adaptability, innovative thinking, and time management. So I would like to give a walkthrough through my code and explain briefly about it. So I have used Python for doing the flattening and creating CSV file, and R for data analysis and summarization. So I'm going to my code. Yeah. So I have used Python for doing the flattening, as I said before, and creating CSV file, and also the R for data analysis. So the given data set, which was given, is a nested JSON file containing copyright infringement notices. Each notice has several works, and each work has multiple infringing and copyright URLs. So here, our goal is to flatten this data for further analysis and extract additional information like the domain and IP address from the URLs. So I have written a function that reads a JSON file from disk and returns the data. This function uses Python built-in JSON module. Next, we need to flatten our nested JSON data. To do this, I have defined two functions, flatten work and flatten notice. These functions traverse the nested structure, creating a new row for each infringing URL and associating it with relevant data from its parent work and notice. So I wrote a code to pass the domain from a URL and resolve the domain to an IP address. Now, we have included parallelization here. So in this step includes creating a multi-processing pool with 4 workers. This allows the script to use up to 4 CPU cores to process data in parallel. So here, flattening and getting the domain and IP address tasks are done in parallel. So once after this flattening and getting domain is and IP are done in parallel, after this, I have saved the file to a CSV file. So once the CSV file is generated, we are giving the CSV file as input for the R program. So coming to my R program, for this R program, my main objective is to derive meaningful insights from this data using various analytical techniques. So to begin with, we load 2 essential R libraries, Tidyverse for meta manipulation and visualization, Lubricate for data time manipulation, allowing us to handle data time more efficiently. So in the first step, we read a CSV file into a data frame, which is a primary data structure for data manipulation in R. We also convert the datasend column to a data format using the asDate function. Here, I have created individual functions for each observation from CSV file and stored in individual variables. Later, we plotted those data. So our first analytical step is to aggregate our data to derive summary statistics. Using the group by and summarize, we count the number of DMCA complaints for each unique value in the description, date sent, IP address domain, and sent name columns. So here we use a ggplot visualization package. So these are the top 5 observations which I made using the data, which I found interesting. So the first one is the top 10 IP address according to the number of complaints that are registered. So out of this, one has a huge number of complaints. And the next thing is the top 5 domains for in accordance with the number of complaints. And the third goes with the top 5 senders of the DMCA complaints. The majority is with the mobile INC, And here are the top 10 descriptions, which we refer to as the movies or series. These are the top 10 descriptions of the given data. And here, this is the daily distribution of the complaints that have been registered. So I feel that, this is not an good efficient data, because the data lies only between the May 3rd and May 24th of the dates. So I feel this is not that sufficient data to be plotted. So, and winding up the session, I found that some key insights during the process. So one is, when without parallelization, the code is taking a lot of time to get executed. So initially, I have done parallelization at a lower level, which is getting the domain and IP function, which is executed for each row. Later, I have tried parallelization at higher level, which is parallelizing the entire flatten work and flatten notice, which has showed a significant speed up of execution time from 70 minutes to almost 3 minutes and lesser time. So this is what I found interesting, and that winds up my video, Professor. And thanks for giving this opportunity. I hope to hear you from the future. Thank you.